The zeroth law of thermodynamics states that if body A is in equilibrium with B, and if body A is in equilibrium with the C, then B and C are in equilibrium with each other. This law may seem trivial, but it forms the basis of temperature measurement. But let us see how zeroth law is used to measure temperature. You can see that here three bodies, object A, object B, and object C. And object C is replaced by a thermometer. And if thermometer C is used to measure the temperature of A, and it measures a temperature, and if again if thermometer C is used to measure the temperature of object B, and if both the readings are same, it means that object A and object B are in thermal equilibrium. So this is the concept of temperature measurement. But for thermometers, we need to identify a property which vary with respect to temperature. Sometimes for normally used thermometers, it is the thermal expansion, or it may be pressure, which varies with the temperature. It can be thermal expansion also. Now, what are the temperature scales? See, for any thermometer, we will identify a property which varies with respect to temperature, like it may be pressure or volume, etc. Any other. And we also need to fix two reference points. That means we can measure the temperature of a body related to these reference points. And these reference points are the ice point and the steam point. See, ice point is a point or the temperature at which the temperature of a melting ice at 1 atmospheric pressure. And steam point is the temperature of a boiling water or steam at 1 atmospheric pressure. So you know that for a Celsius scale it is 0 degrees Celsius, and steam point is 100 degrees Celsius. So Fahrenheit scale it will be different. For any other scale it will be another value. So that means the basis of thermometry is we will identify a property which varies with the temperature, and then we will fix two reference points. Uh, Actually, these reference points are selected because it can be easily reproduced. Now let us see the Celsius scale and Fahrenheit scale. So in Celsius scale, you can see that steam point is 100 degrees Celsius. In Fahrenheit scale, the steam point is 212 degrees Fahrenheit. And it is 0 degrees Celsius. Ice point is 0 degrees Celsius in Celsius scale, and in Fahrenheit scale, it is 32 degree Fahrenheit. You can see the normal body temperature, it is 37 degrees Celsius in Celsius scale and 98.6 degree Fahrenheit in Fahrenheit scale. So now let us see what is a Kelvin scale or thermodynamic temperature scale. See, Kelvin scale is developed in such a way that usually for any thermometer, I have told you the property varies with respect to temperature. And we need to develop a scale which does not depend upon the properties of a thermometer, properties of gas. For example, the property for it will be different for different substances, these properties. And if you develop a scale which is independent of the properties of the thermometer or substance used to measure temperature, we can develop the Kelvin scale. Okay, in Kelvin scale, you can see that we have absolute zero temperature or 0 Kelvin. This is the lowest possible temperature that we can achieve. So the 0 Kelvin is corresponding to minus 273 degrees Celsius in Celsius scale, and it is minus 459 degree Fahrenheit. We cannot go below absolute zero. And the water boils at 373 Kelvin or 100 degrees Celsius, and water freezes at 273 Kelvin and 0 degrees Celsius. Now, a thermometer, a temperature scale which is almost similar to a thermodynamic temperature scale, is ideal gas temperature scale, or you can say it is a constant volume gas thermometer. In constant volume thermometer, what happens is that there is a gas which is kept here, and the pressure of these can be measured using a U-tube manometer. That means by measuring this H, you can measure the pressure of the gas. That means if pressure of the gas increases, that means this mercury rises up, and you can measure this H, and you can easily find out the pressure. And in constant volume thermometer, what we are doing is we need to measure the temperature of a substance, and here this pressure of the gas is directly proportional to the temperature. So that means pressure of the gas increases with respect to temperature, which gives us this equation, that is T is equal to A plus B into P. So if we find out A and B, you can easily measure the temperature of any substance. For example, if you need to measure the temperature of a liquid here, we will immerse this constant volume gas, or this portion, into this medium. At that point, the pressure of the gas increases, and this mercury rises. So by measuring H, you can measure the pressure, and using this pressure, you can measure the temperature of this liquid. That means, for example, we will take two reference points, that is ice point and steam point. If it is a Celsius scale, at ice point T is equal to 0, so this will be A plus B into P. And this is for a steam point, it is 100 degrees Celsius, that is A plus B into P2. You can record the value of P1 and P2. Using the values of P1 and P2, you can find out A and B. Once A and B is found out, you can easily measure the temperature. See, we have already seen T is equal to A plus B into P. That means temperature varies with pressure. But you need only any two reference points to find the value of A and B. But the problem is that for different gases, A and B will be different. For gas A, gas B, and gas C, gas D, A and B will be different. But see, at this point, when pressure is equal to 0, you can see that T is equal to A plus B into 0. So T is equal to A. If you measure this value, this will be equal to minus 273.15. So that means if you extrapolate all these lines, it will meet at minus 273.15 point. Okay. So for a Celsius scale, you can fix this as 0 and this as maybe 100 degrees Celsius, and it will be minus, if you extrapolate it, it will meet at minus 273.15. Now what's the relationship between Celsius and Kelvin scale? So Celsius scale and Kelvin scale related by this equation. That means temperature in Kelvin is equal to temperature in degrees Celsius plus 273.15 Kelvin.